Hello and welcome to Prime Math Tutorials. Today we'll take a look at graphing the function x squared minus 2x all over x squared minus 2x plus 2, and hopefully you gain something valuable out of it. As a side note, you could be given a question that is simply sketch this curve. I've broken it down into 3 simple steps, a format we've looked at in previous videos that should make the question easier to answer, and may be something worthwhile noting down for similar questions in the future. Let's get into it. Now in part A, we are required to find the intercepts. Recall that to find the x-intercept we need to set y is equal to 0, or equivalently, f of x is equal to 0. Doing this, we get the equation 0 is equal to x squared minus 2x all over x squared minus 2x plus 2. Multiplying both sides by the denominator, x squared minus 2x plus 2, we get 0 is equal to x squared minus 2x, which is easy to factor. Taking out the x from both terms, we get the factored form x times x minus 2, which gives us the solutions, or equivalently, the x-intercepts to be x is equal to 0 and x is equal to 2. Now, to find the y-intercept, we need to set x is equal to 0. Well, substituting x is equal to 0 into the function x squared minus 2x all over x squared minus 2x plus 2, we get the equation shown here, which is 0 and 2, giving us the y-intercept as y equals 0. On to part B. Does this function have any asymptotes? If so, we need to find them. To find the vertical asymptote, we need to look at what value of x makes our function undefined. Well, since we are dividing by some expression involving x, we would want to look at where this expression, x squared minus 2x plus 2, is equal to 0. Perhaps you already know that there is no solution to this, implying there is no vertical asymptote. However, if you are unsure whether or not you can factorize it in order to find solutions, something you can do is look at the discriminant of this quadratic expression. Recall that the discriminant, denoted by this triangular symbol here, is equal to b squared minus 4ac. Now, if our quadratic is x squared minus 2x plus 2, then a is the coefficient of x squared, b is the coefficient of x, and c is the constant. Hence, b squared minus 4ac is equal to a negative 2 all squared minus 4 times 2, which evaluates to negative 4. Hopefully, you remember that if the discriminant is negative, there is no real solutions to our quadratic equation x squared minus 2x plus 2 is equal to 0. And if the discriminant is greater than or equal to 0, there is either 1 or 2 solutions. Well, since our discriminant is negative 4, it means there are no solutions, and if there are no solutions, it follows that the quadratic cannot be factorized. Now let's start with seeing if there is any horizontal asymptote. Since we have the same leading degree in both the numerator and denominator, we can take the limit of x going towards infinity of our function. To evaluate the limit, we want to divide the numerator and denominator by x squared, since this is the highest degree term in both the numerator and denominator. Applying this in the numerator, we get 1 minus 2 on x, and in the denominator, 1 minus 2 on x plus 2 on x squared. Now applying the limit to our function will make every term divided by x to some power go to 0. That is, 2 on x and 2 on x squared will both go to 0. This yields the fraction 1 over 1, which is equal to 1. And so we now have our horizontal asymptote y is equal to 1. Now for the last part, sketching the curve. Here, we can write out the information we have accumulated from the past questions and present it in an easy to understand way. Now let's draw up our axes, put in our intercepts, which are at the origin 0, 0, and the other x-intercept 2, 0, and then sketch up our horizontal asymptote y is equal to 1. Now for an additional tip which I suggested in a past video, you can check with the calculator what value you get when x approaches negative infinity and positive infinity. You should get a value approaching 1 from the bottom, for example 0.99 or 0.999, etc. You can put these points in your graph as they will give you an even clearer picture of what the graph is going to look like. Now that we know that the graph is approaching 1 from below and goes through our intercepts that we have plotted, it follows that the graph must have a turning point between x is equal to 0 and x is equal to 2. Using this information, you can get a general idea of the shape of the graph. Hopefully, when you draw a line through these points, you get something like this. In regards to the turning point shown here, you don't need to find the exact coordinate of that right now. Later on, we will use calculus to determine this point. Well, that's it for this video. I hope that helped, and if you have any feedback or questions, please comment. See you next time.